Welcome to the Explainer. Today, we're diving into a really cool sonic puzzle. I mean, how can two simple blocks of wood sound so completely, totally different?
Okay, just take a listen. The first one gives you that clean, ringing clop, right? It just kind of hangs in the air. But the other one, it's this super sharp, dry, almost metallic clack jingle. Think about it. They're both just wood, and you hit them both. So what in the world is going on here? What's the secret?
Well, to really get to the bottom of this, we first have to understand where these things even come from. You see, they're not just random blocks of wood. Nope, they're actual instruments, and they each have a fascinating story.
So, over on one side, you've got the Chinese woodblock. This thing actually comes from the wooden fish that you'd find in temples, used to keep a really steady beat for chants. And its whole design, that hollow body with the slit cut into it, it's all on purpose. It's engineered to create this really clear, long-lasting note. Then, you've got the Indian kartal, and its name, it literally translates to hand clap. And that tells you everything you need to know, right? It's all about providing this super fast, rhythmic, kind of shimmery sound. So you've got one built to hold a note for something like meditation and the other built for pure, high-speed rhythm.
Okay, so we've got two instruments, two totally different jobs. Now let's get into the fun part, the science. We're going to look at why these designs make the sounds they do. And really, it all boils down to one simple concept, vibrations.
Now, both of these fall into a category called idiophones. Yeah, it sounds a little complicated, but the idea is actually super simple. It just means the sound is made by the body of the instrument vibrating all by itself. We're not talking about strings or reeds or columns of air like in a flute. Nope, the wood itself is the sound.
So for the woodblock, its secret weapon is something called resonance. Think of it like this. When you hit it, that hollow space inside acts like a little echo chamber or a natural amplifier. It traps the air as it vibrates and just makes it bigger and louder. That's the magic behind why its sound is so full and why it lasts so long.
And get this, you can actually try this out for yourself. It's a neat little experiment mentioned in the report. Just take a rubber band and pluck it in the air. You get that tiny, weak little twang, right? It disappears almost instantly. Now, take that same rubber band and stretch it over the opening of a hollow box. Pluck it again, boom! The sound is way louder, and it hangs around for much longer. That box is doing the exact same thing as the woodblock. It's using resonance to pump up the volume.
Okay, so if the woodblock is all about making sound last longer, the kartal is its polar opposite. It's all about a principle called damping. Instead of amplifying the vibrations, its solid body is basically designed to soak them up and kill them off, like instantly. And that is what gives you that incredibly sharp, snappy, percussive hit.
All right, so we've got our two big ideas on the table. Resonance, which makes things sing, and damping, which makes them clap. It's like a showdown, right? So now, let's look at the hard evidence. Let's see what the data actually tells us.
And wow, when you look at the numbers, the difference is just huge. The sound from the woodblock lasts more than 5 times longer than the kartals. That's not just a tiny little variation, it is a massive difference. And it's a direct payoff from that hollow, resonant design we were just talking about. And the report itself really hits the nail on the head. The conclusion they came to, that long decay time, that sustain, it's no accident. It is proof positive that a hollow cavity is just fantastic at storing up sound energy and letting it out slowly.
So when you put it all together, this table just lays it all out so clearly. You've got the woodblock using that cavity resonance for a nice, sustained, medium-pitched note. And then you have the kartal, which is all about the physics of a quick impact and super high damping to give you that sharp, high-pitched, almost metallic clap. See? Two different structures, two different scientific principles, and you end up with two completely different sounds. Okay, so we've walked through the history, we've dug into the physics, we've looked at the data. So what's the big takeaway here? What have we really learned from looking at these two seemingly simple instruments?
At the end of the day, the conclusion is crystal clear. It's not just about what an instrument is made of. You could have two instruments carved from the exact same piece of wood, but it's the shape, the physical structure that gives each one its unique voice. In the world of sound, structure is absolutely everything.
It really boils down to this. A hollow body is built to make a sound sing. A solid body is built to make a sound clap. It's just a perfect, beautiful example of how an object's form completely dictates its function, especially when it comes to sound.
And that really leaves us with a final kind of mind-bending thought, doesn't it? If something as simple as cutting a slit into a block of wood can transform a boring thud into a beautiful musical note, just imagine, what other incredible sounds are out there?
just waiting for us to find them. Not by inventing some new fancy material, but just by making simple, clever changes to an object's shape.